Hello everybody, welcome to today's IEEE Smart Energy webinar. My name is David Stankiewicz, your event producer for today's session. I want to thank the IEEE Standards Association and IEEE Smart Grid for co-hosting today's presentation. Before we go ahead and get started and I kick things over to our moderator, I just want to cover a few housekeeping items and let you know how you can participate in today's session. If you have joined today's webinar listening through your computer's speaker system, also known as VoIP, this means you're going to hear today's presentation without dialing in using a telephone. At the end of the presentation, our speakers will be taking questions from you, the audience. You'll have the ability to ask our guest speakers a question using the WebEx chat feature. Just simply type in your question to our host, which is me, David Stankiewicz, and click the send button. At the end of the presentation, we will get to as many of them as we possibly can. We have a full house today, a lot of people on the line, so please bear with us with the Q&A at the back of the presentation. I do also want to let everybody know that we are recording today's presentation, and we are going to make both the on-demand video of the webinar and the PowerPoint slide deck that we're going to go through made available. We will communicate that to anyone who has registered for the event, and we'll let you know where and when to find them. So without further ado, let's go ahead and get started. Rudy, I'll kick it over to you.
Okay, thanks, David. And hello, everyone. Welcome to today's webinar on smart energy and more specifically around the IEEE 2030.5 standard. We've got a great lineup of speakers, and we're going to start off with a bit of background on the standard for some of you who may be a little bit less familiar with it. But then move into a more in-depth discussion on some of the recent developments and the many implementation activities that have been going on in the industry relative to the standard. As David noted, my name is Rudy Schubert, and I'll be moderating the webinar today. The webinar is a collaboration between IEEE Smart Grid and the IEEE Standards Association. My role at the Standards Association is managing the many programs that we have around pre-standards and the post-standards part of the life cycle. So, for example, our Industry Connections program is used to incubate emerging technology topics that lead to the next generation of standards. And on the back end, we do get quite involved with implementation programs such as our community assessment program, as well as events such as this, both in person and webinars that we do that really support the adoption and the use of IEEE standards to accelerate technology implementation. I'd certainly encourage you to check out the IEEE Smart Grid program and its website. It really does provide a wealth of informational resources for folks in that field. Personally, I was involved with Smart Grid engineering projects for about 5 years before joining the IEEE, and I always found the content there quite valuable. As David mentioned, today's webinar presentation materials will be on the IEEE Smart Grid website, and there will be links provided later today on this session, as well as the links being sent out to you directly if you've registered for the webinar. So without further ado, I'm going to move on and introduce our four very well-known industry speakers that we'll have today. Their longer bios were in the webinar announcement, so I'll just do some brief introductions. First, we have Dr. Robbie Simpson. Robbie is a systems architect for GE Grid Solutions, where he guides the architectures for GE Smart Grid systems, particularly with attention to scalability, security, interoperability, and standards bodies activities. From an SA, that's the IEEE Standards Association perspective, we certainly appreciate Robbie in his role as the vice chair of our corporate advisory group, as well as being the vice chair of 2030.5. Mike Burton is a co-founder of Key2 Systems, originally Grid to Home. He's got more than 25 years of experience in the telecom industry, particularly around telecom testing solutions. He's worked extensively with early stage and established telecom companies, developing their strategic plans, business models, product and marketing plans, and guiding them through their life cycle. We've also got Steve Kang on. Steve is the VP of Engineering at Quality Logic, where he directs the development of all the Quality Logic test products, including those for smart grid, imaging, and the fax telecom industries. Steve's been involved in smart grid engineering as well as many other engineering organizations for a long history. And finally, we have James Mader. James is the general manager for Smart Grid at Quality Logic. He is one of the leading experts on smart grid standards interoperability and the maturity of products based on standards. He's involved with leading the Smart Grid business for Quality Logic, and he's a frequent speaker and a frequent writer as well on interoperability in the Smart Grid. We go to the next slide for the agenda. So, just a quick summary of what we're going to be hearing about today. I've just done the speaker introductions. So as I noted, we're going to start out with a bit of background on the 2030 standard, and that'll be a good level set for those of you who need a little bit more information about the standard itself. And then we're going to do that deeper dive into the adoption aspects of 2030.5. It's certainly getting increasing traction within the industry. We'll hear about some of the research projects going on, California Rule 21, some of the deployment scenarios that are happening, its connection to IEEE 1547.1, and then a bit on testing and certification efforts that are underway right now relative to the standard. And then we'll close off by just providing you some other resources and information about how to learn more about IEEE 2030.5. And then, of course, as David mentioned, we'll do a Q&A. We have a very large audience, so we're probably only going to be able to do a handful of questions, but we'll try to make them very interesting ones to the broader audience. And with that, I think we'll just move right into our first speaker, who is going to be Robbie Simpson. Robbie.
Great, thanks, Rudy. Yes, thanks so much. So on the next slide, I'd like to start to dive into the history of IEEE 2030.5. If you've followed this standard or any of these activities for a while, you've probably gotten confused by all of the various version numbers and acronyms that are involved, everything from SEP 1.x, SEP 2.0, IEEE 2030.5. You've probably heard a lot about Zigbee, how that all fits in. So hopefully I'll do a good job of clarifying that for you. So IEEE 2030.5 began its life in the Zigbee Alliance, which is a consortium that focuses on the IEEE 802.15.4 radio and is very involved in the IoT space. The original standard that was created was called Zigbee Smart Energy 1.0. And oftentimes you'll hear folks say 1.x because there's been a 1.1, a 1.2, and collectively we just call them all Zigbee Smart Energy 1.x. It's a very widely deployed standard for the Smart Grid home area network and has quite a lot of functionality of the application functionality that's necessary. So what is in Zigbee Smart Energy 1.x is also included in IEEE 2030.5, along with some additions such as increased support for distributed energy resources and increased support for electric vehicles. The Zigbee Smart Energy 1.x set of standards also has a lot of robust testing and certification with a certification mark. There's over 60 million meters, smart meters currently deployed or under contract from, I think, probably like 6 or 7 smart meter manufacturers, and there's over 550 certified products. So that probably has you asking, well, why do a 2030.5 or a 2.0 version or anything like that if there's already this 1.x standard? And that was largely driven by some input we received back in 2008 from a number of utilities. They were concerned that the Zigbee Smart Energy standard was limited to the Zigbee Pro technology, it's called, which is an 802.15.4 radio running at 2.4 gigahertz and using the Zigbee Pro stack, which is an open standard. I don't want to say it's proprietary, but it is very limited to that particular radio. And there was a desire to branch out and use smart energy over different technologies such as Wi-Fi or home plug or Bluetooth. So on the next slide, you'll see where we began the 2.0 effort within the Zigbee Alliance in 2008. And as I mentioned, the requirements were defined largely by the utilities. There was certainly a lot of other input as well, but it's often good to see utilities get involved and really drive some of the requirements there. And it's designed to use widely adopted technologies. You'll hear more about this in a bit, but kind of our unofficial motto during development, one of our participants, Tom Hertz, always said, don't be weird. So we used very familiar technologies there, like the Internet Protocol, like HTTP that everyone uses for the web, and really worked hard to make certain that the 2.0 version would be something that would be familiar to consumers and easily and widely adopted. In 2012, the Wi-Fi Alliance, the Zigbee Alliance, and the HomePlug Alliance got together and formed an organization called CSIP that was responsible for creating the testing materials for Smart Energy 2.0. And that was quite a successful activity. And in December of 2013, the first version of the test specification and PICS document, which is essentially just a checklist of what you're testing, were completed. Similarly, the standard itself was completed in 2013 and then adopted within IEEE as IEEE 2030.5. So if you hear about Smart Energy Profile 2.0, and if you hear IEEE 2030.5, those are the same thing at this point. So the 2.0 version became 2030.5. Then there's been a lot of industry adoption and uptake and interest since the publication. So in 2013, it was added to the Smart Grid Interoperability Panel's catalog of standards. There was a test harness approved in 2015 from Quality Logic, approved by the CSIP organization, and the first conformance tests were begun by UL in 2015. And then last but certainly not least, one of the largest adoptions recently, it was in California as part of their Rule 21 activities, which you'll hear more about. 2030.5 was selected as the default protocol for California's Rule 21 for communicating with distributed energy resources, in particular solar aggregators and solar inverters. So hopefully that clarifies a lot of the various versions and the history there, and now we'll dive in a little bit further into some overview. Steve?
Next slide, please. Thanks, Robbie, for the history behind 2030.5. What I'm going to present to you is a brief introduction to the 2035 design and architecture. There's a lot of materials and technical information around 2030.5, so what you're going to get is just high-level overview today. 2030.5 really pulled from the best-of-breed and open standards in order to enable wide adoption. So it is a general-purpose smart energy-based protocol, and not just a protocol that's designed specifically for DRLC or DER or messaging or metering. It supports all of that, but it is a general-purpose energy protocol to support devices that's available in a home area network and so forth. So as Robbie mentioned, it leverages really the open standards and protocols that are really widely adopted, such as TCP/IP, HTTP, XML, and so forth. It is what's considered the design was to support transport layer agnostic. What that means is we're not tied to any specific communication protocol, but as long as the protocol supports HTTP and XML, you can communicate and send 2030.5 based messages. The protocol is really designed to enable two types of communication, a client polling for messages from a server, which is more of a active iteration, or subscription based, which is essentially when a resource, some state changes, a server notifies a client of such a change. So it's a much more efficient method. And the choice is really left up to the end device or a client device to decide whether a subscription or polling is used. The standard itself does support data compression, but it is optional to support for end devices. And 2030.5 also allows for easier kind of ad hoc networking mode where there's zero-based configuration. And that's based on MDNS or XMDNS derivative that's also widely adopted. The 2030.5 really has gone through long history of development of test specification along with certification-related tool development. Next slide, please. Function sets is what's really central to the 2030.5 architecture and design. You could think of function sets as kind of building blocks. So when you implement a particular 2030.5 device, you make use of one or more function sets. So there are some mandatory function sets that are required to really enable the central base communications, such as certificates, which are really, required for TLS communication that comes into play when you're doing HTTPS, and other really basic function sets, such as device capabilities, which lets client device know of a server's capability, what type of features are available from a server, for example. And also we talked about a zero-based networking configuration, which is enabled through MDNS. And then to implement a device that in a business usage scenario, such as a metering program or a DER program or a demand response function set, these are what's known as smart energy function sets within the 2030.5 standard. And to implement that device, such a device, you need to implement one or more smart energy function sets, such as DER, metering, DRLC, pricing, etc., and also leverage the mandatory function sets and optional function sets that are required. Next slide, please. So this is just a kind of quick overview of some important function sets that was approved in CSIP's Phase 1 stage. So that includes a core function sets on the top that are in brown, and also optional function sets that are in the green rows. And as I share with you on the presentation, to implement a device that actually serves a business purpose, such as DRLC or DER, you need to implement the core function set plus the optional. And the two columns on the right describe the number of tests that were defined for conformance and certification purposes. Next slide, please. So this is another pictorial just to reiterate the importance of function sets. They're essentially building blocks or tool sets that a implementer pulls from. So you will, in order to implement a device that for DER, for example, you not only implement DER function set, but you also need to pull in the core function sets and other optional. Next slide, please. So DER and 2030.5 has been a very hot topic, mainly due to California Rule 21 as well as Hawaii Rule 14. So the 2030.5 supports the full Rule 21 Phase 1, along with Phase 2 and Phase 3 function sets that are described in California Rule 21. Not only that, it has a full support for metering, and as I mentioned earlier, it is a general-purpose smart energy function set protocol. So not only DER, but metering, DRLC, and so forth. It also enables monitoring and alarms for situational awareness and logging and measurement and verification. And it supports the full complement of the curve-based as well as immediate-based DER controls that are described in Rule 21. It also supports the function sets that are described in California Solar Initiative Implementation Guide, or CSIP, and that is the ability to group and target multiple groups of individual devices or DER devices. From an architectural perspective, you really 2030.5 was modeled and architected to really make use of best of breed from the open standards that are out there. So again, HTTP and use of IP is widely adopted, as you all know, and it does support security through TLS 1.2 and specific cipher that are specified in the standard itself. It is an open standard that's currently published by IEEE. So that's widely available from IEEE for those interested. So you could go to IEEE and download a full specification today. DER information model was harmonized with 61850 and SunSpec. So you would have, it supports interoperability across these standards. And finally, 2030.5, just to reiterate again, it is a general purpose home energy-based protocol. So DER as well as other smart energy function sets are supported. It supports a residential as well as commercial and industrial type of environments. So with that, next slide, please. So let me hand it back to Robbie for an update on the standards.
Great, thanks, Steve. So IEEE 2030.5, as I mentioned earlier in the history section, was completed in 2013. Following that, in 2014, we opened up what's called a maintenance PAR. PAR in IEEE lingo is project authorization request. This is the way new standards are created or standards are revised, things of that nature. So this maintenance PAR essentially allows us to revise the standard and correct any issues that may have come up or do any bug fixes that may be necessary. And essentially we've gotten input from three major sources. The first being feedback as people begin to implement the standard and get some real field experience using the standard. They're able to provide feedback and identify potential bugs or just issues that we may find. The second is feedback from the needs of California's Rule 21 and other DER implementations, distributed energy resource implementations. So for instance, there may be new controls that are needed for solar inverters and things of that nature. And then lastly, IEEE has another standard, IEEE 1547, that's very focused on distributed energy resources. And that standard has recently gone through a revision. And so we're taking feedback from their revision and making certain that the two standards stay harmonized and work well together. So as a result of that, since from those three major sources and any other things that may have come up, so far we've received 212 comments, which I don't know that giving you the number does much good, because some of these comments are, may take no effort whatsoever. They may be something simple and editorial, and some may be a little more technical. But the good news is we the IEEE 2030.5 working group, have gone through all of those comments and addressed them as a group, come to consensus on how to respond to the comment and how to address them. And we're now in the process of editing the document and getting all of the changes incorporated. So we expect to publish a new version of 2030.5 with these changes. And I should note that, under the auspices of a maintenance PAR, these aren't going to be major changes. So don't think that standard is changing drastically or anything like that. And so we do expect a publication of a 2017 version in the fourth quarter of this year. So of course, I welcome everyone to join us. And if you have an interest in 2030.5, I'm sure that any one of us are happy to help you get signed up and able to participate in the working group. So with that, I'll turn it over to James Mader to talk about research projects.
Thank you, Robbie. So next slide. So there are a number of research projects going on, as not surprisingly, a lot of them are being funded and conducted in California. which is the leading edge in implementing 2030.5 for DER-specific applications. So the first project to mention is one that was called Standard Communication Interface and Certification Test Program for Smart Inverters. This was concluded last year. It was funded by the California Solar Initiative and managed by EPRI with partners SunSpec, Sandia Labs, Underwriters Labs, Key2, Fronius, SMA, Quality Logic, SMUD, which is Sacramento Municipal Utility District, and Southern California Edison. And the primary purpose of that, and it was done successfully, was to demonstrate that you could communicate using both IEEE 2030.5 and OpenADR. You could communicate the primary smart inverter functions to a gateway, which would then use the SunSpec protocol to actually program or put the programming into the smart inverters. Second project I want to mention is another one funded, this one by the California Energy Commission. And it's titled Certified Open Source Software to Support the Interconnection Compliance of DER. EPRI is managing this, again with partners SunSpec, Xanthus Consulting, Quality Logic, and Enphase. And this project is intended to do two primary things. One, it's developing an open source client, a 2030.5 open source client, which will be made available by EPRI, we believe sometime next year. The second thing is to develop and demonstrate, actually take a product through a DER-specific certification program aimed at qualifying products for California Rule 21. Next slide. Another project also going on at this, in parallel, is called an Impact Assessment and Secure Implementation of California Rule 21 Phase 3 Smart Inverter Functions to support high PV penetration. So this is also California Energy Commission funded, managed by EPRI, and with SunSpec, UCSD, University of California, San Diego, and the company Sunrun. This is really to look at the Phase 3 functions, which are more advanced functions for smart inverters that have been defined in California and are being included in the IEEE 1547 and 2030.5 standards, and also to assess cybersecurity and to actually deploy and understand the digital certificate infrastructure needed to support the requirements for the communications. There's also a separate project going on. It's a U.S. DOE-funded project. It happens to be in California, but that's more happenstance. It's being done by SLAC, and SLAC was originally called the Stanford Linear Accelerator Center. It now has become more of a general research center, and a California company called Casensum. They're developing an open source DER management system using the open source Voltron platform and IEEE 2030.5. So what they're going to be doing is adding 2030.5 support for demand response and DER functions to the Voltron platform. So next slide, please, Rudy. So the Department of Energy is running something called a Grid Modernization Lab Call, where the various labs that work on smart on energy, especially smart energy, are working together on specific projects. There's one project led by NREL on interconnection and interoperability. One of the standards that they're looking at is the 2030.5 standard. They're doing a gap analysis to look at it in the context of DER with a larger definition beyond solar PV and smart and battery inverters. one of the things they want to do with that is not only understand it in the context of a larger DER definition, but then develop some test procedures to understand how to actually experiment with using a standard protocol for managing a portfolio of DER products. Like I say, they're looking beyond the current IEEE 1547 to include controllable loads, and basically that means demand response and electric vehicles when they're charging. That project is ongoing it started in April of last year and will conclude in March of 2019. So next slide. In Korea, Korea has been very interested in 2030.5 as a protocol for managing demand response in residences. The government of Korea has funded a number of specific development projects to actually implement 2030.5 in both servers and clients for demand response. And the list I have here are projects that have specifically gone through a conformance test with a local Korean lab PTA using the Quality Logic CSIP approved test harness. And what you see is a list of 6 companies here. There are reports of the testing on our website. So you can see that there's a server for energy demand response, a client for energy demand response, also another client, and a couple more servers. So again, these are all projects to prove the concept that you can implement 2030.5 and use them for demand response. And these are, again, being done in Korea. Because they also have adopted the OpenADR protocol, the Korean Electric Research Institute is working on a conversion program from OpenADR to IEEE 2030.5 messages. So next slide. I think that's it for the update on research projects. So I'm going to turn it over to Mike Burton for a California Rule 21 update and deployment update. So Mike.
Good day to everybody. I'm not sure which time zone you're in, so I just say good day. So my name is Mike Borton. I'm going to talk to you about what California Rule 21 is about. Maybe you've heard this term in this presentation, and you might be asking the question, what is Rule 21? So to give you a background on that, really, it's in California and in Hawaii, we're both suffering from renewable energy overgeneration. Basically, the overgeneration is meeting the base load, and we are getting grid trips due to the voltage rising. So there was a doomsday duck curve put out by the ISO that said that by 2020, then this will be at a critical point where we'll see a lot of these trips. The bad news is that we're already starting to see those trips, so there's a rather acceleration of trying to solve the problem. So this started with a recommendation to form what's called a Smart Inverter Working Group. And there was divided into 2 phases. Phase 1 were independent things that the inverter could do without any communications. And phase 2 recommendation came out to use 2030.5 to communicate to be able to change those parameters. Okay, so that's where we are. It didn't, and I'll explain a little bit later, it didn't define that everything shall be 2030.5, but the signal coming from the utility shall be 2030.5. Next slide. So talking about the Smart Inverter Working Group that was formed in California, the phase 2 sort of generated its output. The recommendation was approved by the local CPUC. There's work going on in Hawaii to do something very similar. The result of that approval by the CPUC was a common smart inverter profile that was generated. It's a document that says how the protocol shall work and how it shall be used. There are changes now for things that are going into phase 3 of this requirement of adding new functionality, and that's what Robbie talked about earlier. Next slide. So the key requirements of that ended up with a single default mandatory communication profile, and that's what's documented in the CSIP guide. All inverter-based DR systems shall be capable of communications. The date is sometime in 2018 that will be mandated. The date is actually driven by the certification process for this standard, and specifically the DER functionality. It's really not intended for subsection interactions protection. What it is it downloads curves or sends some controls for the behavior of the smart inverters. So each smart inverter may end up having to play a different role in the grid, and so it has the capability of sending these behavioral curves down there. As we talked about earlier, the default protocol is TCP. The application layer protocol is basically 2030.5, and the implementation guide actually defines how that uses. That implementation guide is available on the internet. If you just search for it, it's known as CSIP, CSIP. There is a common test harness and third-party certification processor is underway. Everybody expects that to be completed this year, and basically the utility is intended to mandate the inverters to have communications between 9 and 12 months from that date. Now, the CPUC regulation said that with mutual agreement between parties, Rule 21 may use DMP3 or IEC 61850. So it's not an exclusive thing, but at the moment everybody's working on the principle that it's 2030.5. Next slide. This diagram in the blue background is basically extracted in the CSIP guide. So if you get a chance to open the CSIP guide, you'll find this diagram there. And it's basically the scope of it. Without looking at the blue and the green bubbles, behind that is basically on the left-hand side, the utility communicates 2030.5 commands and receives 25.30 responses back from either an aggregator, which is that middle box in the middle, or from a plant's communication gateway. So if you've got a large plant, it may be a communications gateway, or you actually can talk residential to residential inverters directly, although I would say that most IOUs are preferring to talk to aggregators. So there is a 2030.5 server in the red bubble there in the middle at the left-hand side that says there is a server in the utility. In the aggregator or the plant communications, there's a client, and in the residential communications, or actually in the inverter, in some cases the gateway is inbuilt into the inverter, there will be a 2030 client. That is what is mandated. So if an aggregator does not have to have a 2030.5 client from an aggregator or the plant into the inverter, but as you can see, there is a requirement to have 2030.5 for residential use. So a lot of inverter manufacturers are actually assuming that they'll end up with 2030.5 in the inverter. The green bubbles show that you don't have to have those. They're not mandated. It's just the red bubbles are mandated by Rule 21. Next slide. Okay, a little bit of a picture about deployments. Next slide that I want to talk about. I can't really talk about specifics, but because a lot of this stuff is rather under wraps and under the NDA but there's work going on in the utilities. Basically, there is already a California IOU that's deploying a test system and is in procurement for a production system. They will be field testing with an aggregator this year. Another IOU has completed field testing with aggregator, and next step is a production system. And another California IOU is actually testing a different deployment method. Typically, the deployment method at the moment is through the internet, but another IOU is looking at a different method through their AMI network. Aggregators are active in developing, and as you see, there are already some field trials going on with aggregators. Several deployments are underway with inverter monitoring companies. So if you're an inverter monitoring company, the natural progression is become an aggregator too, because you're already communicating to the inverter. And of course, we've got the smart inverter manufacturers, both solar and battery storage units, that have completed development and are in testing with utilities, and we expect to see a lot more going forward. Next slide. Back to James.
A few minutes to finish up here, so next slide. So IEEE 1547 is undergoing a revision and is in balloting right now. The importance of that from an IEEE 2030.5 standpoint is that both the California Rule 21 and the IEEE 2030.5 are following the lead of the IEEE 1547 in terms of smart inverter functions. So that draft is in ballot now, expect approval this year, with a new standard to be published later this year or early next year. So there are new smart inverter functions such as required VAR capacity and capabilities and ride-through of disturbances. There's also now some testing requirements and a requirement for support of at least one communications protocol. This is really brand new and quite revolutionary in the smart inverter world. So there are 3 protocols named, the IEEE 1815 or DMP3, the IEEE 2030.5 or SunSpec. So, and the next thing that the 1547 group is going to tackle is to really refine what it means to be interoperable and how do you test and prove that the inverters behave interoperably using one of these protocol standards. So that's very important to IEEE 2030.5 to have this. So next slide. So I wanted to do a quick certification and testing update. So Quality Logic, as was mentioned by Robbie, developed the certification test tools that were approved by the Consortium for SEP2 Interoperability, or CSIP. I'm sure people are confused by now. And we've partnered with Underwriters Labs and TTA to provide conformance testing. It's not a formal industry certification program, but it does run through the tests on a product, and we've tested 9 products to date. In California, IOU's advice letter for implementing Rule 21 communications, the requirements were approved in April 2017, or April this year, and one of those requirements is that certifications will be required 9 to 12 months after there is an industry certification program that is specifically for California Rule 21 DER. And that's scheduled for later this year. Now we got 2 players. The Wyson Alliance inherited the CSIP documents and the CSIP certification model and is working to implement that worldwide, including security certificates. The SunSpec Alliance is working very specifically on a DER certification program that will become the California one, or that's the expectation. We're working with them to help design that as part of a project we're working on. Next slide. So their schedule is actually this month or early next quarter to deliver both a protocol it's supposed to be protocol implementation conformance statement, or in this case, an information conformance statement, and the first review draft of the test procedures for the DER-specific systems for California. And then by Q4 of this year, there should be a test and certification program in place to evaluate and certify DER systems for 2030.5 compliance. And that will start the clock ticking on the 9 to 12 months for mandatory requirement. So with that, so next slide, I think I turn it over to Rudy, and I think we got some resources, and then we're done.
Thanks, James. Yeah, this one slide that we've put up here, really just providing you links to find more information about 2030.5. The first one is if you are interested in the activities of the working group, there's a link to the IEEE Standards Association page regarding the working group on it. We also have a link there for those who are interested in getting getting a copy of IEEE 2030.5. And third link on there, there was an earlier webinar that Robbie delivered back in the fall. So, if you're looking for a bit more information, a lot of the basics of what is in 2030.5, that's an excellent webinar that's available through the IEEE Smart Grid website. And then finally, I wanted to mention that we ran a symposium. The Standards Association put together this event, working with James. Actually, all the speakers were an integral part of the planning on that one. And all the presentations from the workshop that we ran last November are also available through the IEEE-SA website. I know it's hard to write these things down as you see them on the screen, but again, we'll be making the slides available to everyone afterwards, and we'd encourage you to check those links out. And I believe at this point we're moving to questions. So we have about 15 minutes. We have quite a few questions. I don't know if we're going to get through all of them, but I'm going to open up the first one for the panelists. The first one is on how can IEEE 2030.5 be made useful for EVs? Examples would be helpful. So perhaps Robbie wants to start off as our resident vice chair of 2030.5.
Sure, thanks, Rudy. So for electric vehicles, there's a lot of functionality in 2030.5 that can be useful. There's the pricing function set, or price communication, so that an electric vehicle could know the rate or tariff of the electricity that it's consuming, or if it were possible to do the vehicle to grid capability with the electric vehicle, it could also know the price for generation. So anyway, the pricing capability. Similarly, there's the demand response and load control function set that can be useful for electric vehicles. So you can do participate in demand response programs. There's actually some specific capabilities in IEEE 2030.5 for electric vehicles called flow reservation that allows for the staggering of charging or the scheduling of charging. Because as you can imagine, if you had a large fleet of electric vehicles, or say a neighborhood with many electric vehicles on a feeder or on a transformer, you may not want them all charging at the same time, so there's mechanisms for scheduling those charging. And then, of course, a lot of the DER functionality could be useful for electric vehicles, particularly if you do have that vehicle to grid or kind of feedback into the grid capability with the electric vehicle.
Okay, thanks, Robbie. I'm going to throw the next question out, I think, to James and Mike, who spoke a bit on some of the activities that are going on. And somebody asked the question, are there any projects or research activities relative to 2030.5 devices going on in Saudi Arabia or the Middle East?
Not that I know of. Mike, do you know of any?
Not that I know of either.
Okay.
Sorry.
And just to add a comment to Robbie's, but the SCE have based all of their communications electric vehicle standards on 2030.5. So if you have a look at the SCE communications requirements for electric vehicles, you'll find them all based on 2030.5.
All right, we'll keep going. Their questions are starting to come in faster than I can read them. But one of the early questions we had was, as a power system becomes cleaner, more of the clean energy is surplus at certain times of low demand or high production by renewables. Does IEEE 2030.5 have the functionality to allow consumers to use surplus clean energy on an interruptible basis?
Whoa, who wants to take that one? That's a good question. So
this is Robbie. I'll take a stab. So IEEE 2030.5 does have the capability, for instance, for pricing, and we've even seen situations now where in some jurisdictions there's so much surplus energy being generated that there's even negative pricing. And so one could use 2030.5 to communicate that pricing to let the consumer manage the energy on their own. Maybe they'll want to store it instead of feeding it back into the grid, or even curtail their generation. Similarly, with the DER function set, there's capability for actually requesting curtailment and even the ability to have various curves, and if there's say frequency conditions or various voltage or bar related issues, you can have curves where they can where an inverter could autonomously react to those grid conditions. And so there's a tremendous amount of what I would say kind of more control capability, as well as the more autonomous capability with pricing.
Yeah, basically, I'll just chime in on that. Basically 2030.5 is a very good communications protocol once you've figured out what you want to do with the energy. It's great for communicating, that different devices behave in different ways. A battery could be storing, for instance, or you could scale back the solar PV output or something like that. But you get into if you want consumers to participate in a more active marketplace, that's a little more difficult, and there are no standards that really support that very well at this point.
I'll go on to, we have that are somewhat similar, so I'll just summarize them as asking about the relationship between IEEE 2030.5 with IEC 61850.
So I think we're all competent to take that. Who's most involved with the 61850 stuff? Is that you, Robbie, or?
Sure. So the IEEE 2030.5 working group, the 1547 working group, SunSpec, and IEC 61850 working groups have all been working quite closely together to make certain that the way we model DER specifically is harmonized. In other words, the control functionality that we have and the way that we do our measurements and things of that nature, we've done a lot of work to make certain that those are all synchronized and are done the same, because we recognize that people are going to use multiple standards in many cases, and we'll need to be able to easily translate between those. So yeah, very well harmonized, and in fact the DER functionality in 2030.5 was originally based on work from EPRI, from the IEC 61850 community, and from the SunSpec Alliance, and we're continuing to work together going forward.
And the California Rule 21 actually specifies that any communications uses an IEC 61850 information model.
I'll move to the next question, and again, I'm going to try to lump a few questions that came in together, essentially asking about cybersecurity considerations built into 2030.5 and what precautions should new adopters take to assure there is no increase in visibility.
So this is Robbie. I'll take another stab, and hopefully folks feel free to chime in if I miss something. So first off, 2030.5 is a communications protocol. So there's some aspects of security that we do not focus on, like physical security, for instance, which should be something that implementers think about as well. But in terms of communications, the underlying standards that we use, for instance, TLS, is quite robust and has been hammered away on by the whole planet at this point. It's the same standard you use for your online banking and things of that nature, or the little padlock in your web browser, if you will. With that standard, you can specify, with TLS, you can specify different cipher suites, and the cipher suite that we're using is an elliptic curve Diffie-Hellman ephemeral cipher suite, which essentially is the latest and greatest, if you will, for security, and is part of what's called the Suite B set of standards, and these are all recommendations from, for instance, the U.S. NIST. And then we have mechanisms in there for access control. We use the certificates themselves for authentication, et cetera, et cetera. There's provisions in there for encryption. So we are using the kind of the latest and greatest, if you will, in terms of internet security standards. And I would also mention that we have a capability for doing updates as well. There's a file download, it's called function set, that allows for devices to be updated should there be problems in these underlying protocols that are discovered, or if a specific implementer may have a bug or some sort of security vulnerability in their product. They can use this functionality to download a firmware update, for instance.
Just adding on to Robbie's comments about cybersecurity, there's additional features in 2030.5, such as PIN numbers and identifiers, along with what Robbie mentioned as access control. And that gives the server ability to assign or hide specific resources from clients. So it actually has additional features to support cybersecurity aspects of it.
All right, we just have a few minutes. I think we can get 2 or 3 more questions in, possibly. There's a question on how is 2030.5 going to help home automation systems in the presence of distributed energy resources?
Well, I think Robbie sort of addressed that before. I think the answer is it provides a protocol for if home automation systems want to tap into the energy marketplace, and especially tap into utility programs that require communications to their home energy systems, then 2030.5 may be one of those protocols that is actually used between a utility or an aggregator and their smart inverter. So Robbie or Mike, or if someone wants to add to that?
Yeah, so there are some projects ongoing right now where people are building local energy management systems that could be combined with a home automation system that would manage energy type of resources. So they include things like battery storage, solar inverters, and electric vehicles, as an example.
And I would also add that the choice of protocols that we made, this kind of unofficial motto of "Don't be weird," came in handy in the sense, will come in handy in the sense that it makes it very easy to integrate 2030.5 into home automation platforms. If you look at what's out there right now with Apple's HomeKit and Google's Nest and all of these various home automation ecosystems and standards, the vast majority of them use very similar underlying technology. So it would be relatively easy for these systems to be integrated. 2030.5 certainly isn't meant to be a home automation standard, but it was certainly designed with communication to the consumer in mind.
Right. Let's see if we can squeeze one more in. For some applications, I assume two-way communication is needed, but is it possible to use 2030.5 essentially as a broadcast within a building to distribute price signals for one-way communication?
The answer to that is no, not really, but there is a mode called function set assignments that allow you to group a single command to address multiple devices at the same time via an aggregator. So if you wanted to broadcast a message to 1 million inverters out there to several aggregators, it would only be a single IEEE 2030.5 command to do so, if the same information is required to go to all the inverters. So the answer is it does require two-way communications because it likes to see a confirmation that the command has been done. Using function set assignments, you can create a single command to address multiple inverters, for example, or multiple end devices.
Yeah, not just inverters, but it could be, demand, could be thermostats, could be air conditioning systems, whatever is in a building. So, yeah, interesting question.
All right. Well, we're just about at the top of the hour. We got through about 75% of the questions. For those we were unable to get to, apologize. A lot of really great questions. So at this point, I'll say thank you, and I'll also turn it over to David to see if we have any last logistical questions. But as you see up on the screen, again, you'll be able to information on the IEEE Smart Grid website. David, any last housekeeping things we should let people know?
Thanks, Rudy. No, just this final slide if you want to get involved with IEEE Smart Grid on social. Here's the links to follow them on the following 5 platforms. And that is it. We had a lot of questions about, again, the availability of the slides and the recording. Again, they're both going to be made available to every participant who was here with us today. And I just want to send us out with a thank you to you, Rudy, James, Robbie, Mike, and Steve for your time and participation. We really do appreciate it. Thanks for joining, everybody.